Ground-based telescopes are subject to a series of limitations imposed by the atmosphere and the terrestrial environment. The first of these is light pollution. Most people in the United States and most people in the world now live in urban or suburban areas where the night sky is not nearly as visible as it was to humans throughout history when there were no city lights or artificial lights of any kind. This limits our view of the distant universe, often severely. I'm lucky enough to live in Pima County, one of the few in the United States in southern Arizona where there are strict lighting ordinances designed to protect professional astronomy from light pollution. This involves shielding lights from upward glow, limitations on commercial lighting, and in particular it involves the use of low-pressure sodium lights for standard street lights, which give far less scattered light and radiation than high-pressure sodium. In this picture of the United States, taken at night, you can see that doing astronomy east of the Mississippi is a losing proposition. There's almost continuous urban and suburban glow. The western United States still has some good locations for astronomy, in California, in Arizona, in the Sierras, and a few other places. But things are getting worse. Here you can see how the light pollution has changed in the last 50 years, and even projecting it forward to 2025, astronomy is going to be very difficult in the continental United States. This affects everyone, not just professional astronomers. Most young people are unaware of the existence of the Milky Way or the simple phenomena of the night sky because they've never seen it. Major observatories for research astronomy are located in just a handful of places. In fact, most of the world's large telescopes are in two places. One is Mauna Kea in Hawaii, which is a dormant volcano at an altitude of 14,000 feet, and the other place is a set of sites in northern Chile where the skies are dark, the air is clear, and the infrastructure for the support of astronomy is excellent. The University of Arizona already has 2 telescopes in Chile, and we're planning on building a very large telescope in the future. There are a few other places with large telescopes. The Canary Islands, the southern part of Africa, the dark parts of New South Wales in Australia, and Russia has a telescope of 6 meters diameter. The places astronomers go to observe the deep, dark night sky are clear when you see a picture of the world at night. The United States is of course flooded with light, as is Western Europe, as are large parts of Asia. There are just a few places where the skies are pristine and dark. Africa is one of those places, but astronomers also like high mountaintops to escape above a lot of the water vapor. And that brings to prominence high mountain ranges such as the Andes and the extinct volcanoes in Hawaii. These are the places where most of the world's large new telescopes are being built. The second major limitation imposed by the Earth's atmosphere is the blurring or twinkling of starlight caused by turbulent motions, mostly in the upper atmosphere, far above where most of the weather occurs. This is a fundamental limitation because the blurring of an image affects the depth that a telescope can reach in space and the sharpness of its images. Here, comparing a view of the same star cluster with a Hubble Space Telescope and what you would see with a ground-based telescope of the same aperture, the dramatic effects of this blurring are clear. Astronomers call this seeing. The third major impact of the Earth's atmosphere is that it's opaque at most wavelengths across the electromagnetic spectrum. If we look schematically at the electromagnetic spectrum from gamma rays to radio waves, you can see that only a few spectral regimes are able to penetrate the Earth's atmosphere. That is the visible range, the sensitive range of our eyes, and a large part of the radio spectrum, plus a few segments of the near-infrared radiation that's beyond the wavelength the eye can observe. For large tracts of ultraviolet, X-ray, gamma ray, and millimeter waves, the atmosphere is essentially opaque. We cannot see celestial objects, and for that we have to go into space. Astronomers always want bigger and bigger telescopes, but this comes at a cost, and it's a big cost. We want bigger apertures, but that aperture, that mirror, has to be placed in a structure, and that structure that holds the telescope has to be contained within a building to protect the telescope and house the astronomers. And not surprisingly, this results in a cost curve, or almost a law, by which the price of telescopes can be estimated. And the price of a major telescope goes as the 2.5 power of the diameter. That's quite a steep dependence, and it means that as we project forward to even larger facilities, we're looking at costs that may become prohibitive unless we use some clever tricks. We've seen that there are 3 limitations imposed on ground-based astronomy. One is caused by light pollution. That's omnipresent in urban and suburban areas of the world, and it's driving astronomers to just a handful of locations at the top of high and remote mountaintops in several places in the world, primarily Chile and Hawaii. The second limitation is the blurring of the Earth's atmosphere. Astronomers have in fact developed some tricks to overcome that. But the blurring limits the depth and power of any telescope. The third limitation is the opacity of the Earth's atmosphere to most forms of electromagnetic radiation. Except for the small sliver of visible waves and a large chunk of the radio spectrum, all other bands of electromagnetic radiation are extinguished by the Earth's atmosphere. To observe them, we have to go into space.